In the extension to the two carts lab, we're going to observe a person being pulled on a scooter and use a motion detector to describe their motion. Let's see that again, but this time with the motion detector collecting data. The top graph is distance versus time, and the bottom graph is velocity versus time. The top graph is a distance versus time graph. We can see that the distance versus time graph is a curve, which means every second the cart is covering more and more distance. In the first second, it went up this amount. In the second second, it went up that amount. In the third second, it went up even more. It's covering more and more distance each second. The velocity versus time graph, we can see, is a line slanted up to the right. At the end, over here, the motion detector stopped picking up the motion. So we can ignore that piece. A velocity versus time graph that is a slanted line shows an acceleration. We can find the acceleration by finding the slope of the line. To find the slope of the line, we need 2 points. The first point is right here. That point is 0.25, 1.03. We'll pick a second point out here at 2 seconds. That point is 3.35. We get that by looking at the data table right here. The slope of a velocity versus time graph is the acceleration. We plug in our 2 points, 3.35 minus 1.03, divide that by the time, 2.0 seconds minus 0.25 seconds, and that equals 1.3 meters per second squared. That means the velocity increased 1.3 meters per second every second that the cart was pulled. We worked out the acceleration to be 1.3 meters per second squared. We can see that all these accelerations are right around 1.3 meters per second per second. If we look at the velocity, we can see that the velocity is increasing every 0.25 seconds. But we know the acceleration to be 1.3 meters per second squared, which means the velocity is increasing 1.3 meters per second every second. After 1 second, the speed is 1.96 meters per second. If we add 1.3 to that, we get 3.26. 1 second later, at 2 seconds, the speed is right around 3.3 meters per second. The speed's going up 1.3 meters per second each second. We can see that as time increased, the position was increasing more and more each second. From here, it went up about 0.2 meters. Here it's about 0.4 meters, 0.5 meters, 0.5, 0.6, 0.7. We can see the cart was covering more and more distance each second. For an accelerating object, the distance increases more and more each second, and the velocity increases the same amount each second.